In this video, we're going to be talking about a concept in probability theory called conditional probability. And to do that, we're going to need two events. So we're going to say that event A is that we've drawn a face card. And event B is that we've drawn a heart. So let's just draw out our basic Venn diagram to talk about our probability space. So we have our Venn diagram, which is just our rectangle. And we have two events in there. Event A, which is that we've drawn a face card. And we have event B, which is that we've drawn a heart. So what conditional probability means is, what is the probability that a given event happens, given that another event has already happened? So for our example, let's say that you're being dealt a card, and you just see it flutter, and you see that the card is already a heart. And you want to know that now that it's a heart, what's the probability that you've actually gotten a face card? So what's the probability that you've gotten a face card that is a heart if you already know that your card is a heart? So the way that we write out that is we write the probability that we've gotten a face card, so the probability of A, given, so this vertical line means given that we've already gotten a heart. So the probability of A happening, given that we know that B has already happened. So if we want to think about this in terms of our Venn diagram, what's happening with our Venn diagram is since B has already occurred, the rest of the probability space is no longer available. So everything slashed out with red is no longer an option because we already know that B has already occurred, so B is our only option left. So now that we know that B's happened, we want to know that what's the probability that A happens, which means what's the probability of just this little sliver happening. So the formula for that is the probability of A given B is equal to the probability of A intersect B, because we know that both A and B have to be satisfied, divided by the probability that B has already happened. So this is taking our entire solution space and slicing it all the way down to just B already happened. So we have the probability of B here on the bottom of our fraction. And now we're trying to figure out the probability that both A and B occur. So we're looking at that intersection of A and B. So what fraction of B is also part of A? So for our example, let's look at that. So we have the probability of A intersect B is equal to, we have a face card that is a heart. So we have only three options. So we have 3 out of 52. And we have the probability of B, which is that our card is a heart. So we have 13 out of 52. So we can then write our probability formula. So we have probability of A given B is equal to the probability of A intersect B. So we have 3 out of 52 over our probability of B, or 13 out of 52. So from previous math classes, we know we can simplify this to say that we have 3 over 52 times 52 over 13. So our 52s cancel out, and we just get 3 over 13. So if we think about that, that makes pretty intuitive sense, is if we've drawn a card and we know that card is a heart, what's the probability that we have a face card? So we can just look and see that we have 3 face cards inside of our heart suit. So we know that it's a chance of 3 out of 13. So we know that the probability of drawing a face card, given that the card is a heart, is 3 out of 13.